All right, let's talk about one of the most common questions that comes up in the world of ZFS. You've got 4 brand new hard drives ready for your server, but what's the absolute best way to set them up? You'd think it would be simple, right? But the choice you make here has some pretty huge consequences for performance, for reliability, and even for how you might expand your storage down the road.
So this is it, the core dilemma. This is the starting point for so many of us building home labs or servers for a small business. And look, the answer is definitely not one size fits all. This decision is a classic trade-off, and by the end of this, you're going to know exactly how to make the right call for your specific needs.
So let's frame this whole problem. When you've got 4 drives, the debate almost always boils down to 2 very popular but very different configurations. You can think of them as the 2 main contenders, kind of battling it out for your data.
So on one side, you've got the striped mirror, which is basically like a RAID 10. You take 2 drives and make them an identical mirrored pair. Then you do the exact same thing with the other 2 drives. The system then writes data across both of those pairs at the same time to really boost the speed. And on the other side, we have RAID Z2, which is ZFS's version of RAID 6. Here, all 4 drives work together in one big group, and 2 of them are dedicated to storing parity, error-checking data.
Now, to really get this, we need to quickly define a key term, the VDEV, or virtual device. This is the absolute basic building block of any ZFS system. The easiest way to think about a VDEV is like a single Lego brick. This brick is what provides the redundancy. So in our striped mirror example, each one of those mirrored pairs is one VDEV. It's one Lego brick. And then, built on top of the VDEVs, you have the Z pool. This is the final storage space that you actually see and use. So if VDEVs are the Lego bricks, your Z pool is the entire Lego creation you've built with them. So for our striped mirror setup, you have a Z pool that's made of 2 mirror VDEVs. But for the RAID Z2 setup, your Z pool is made of just one single RAID Z2 VDEV. And believe me, this distinction is absolutely crucial.
All right, so you might be thinking the next logical step is to figure out, okay, which of these setups gives me more usable storage space? And this is where we get to a really fascinating and pretty powerful insight that actually makes our entire decision way easier.
So let's just ask the question directly. We've got our performance-focused layout and our redundancy-focused layout. Which one actually lets you store more of your files? The answer is probably not what you're expecting.
The answer is neither of them. With a 4-drive setup, both a striped mirror and a RAID Z2 configuration give you the exact same usable capacity, 50% of the total raw storage. It is a complete and total tie.
So here's how that works. In the striped mirror, each 2-drive mirror gives you 1 drive's worth of space. Since you have 2 of those pairs, you get 2 drives worth of usable space out of 4 total drives. That's 50%. Now look at RAID Z2. You have 4 drives, but 2 of them are used for parity. So what are you left with? 2 drives worth of usable space. Again, 50%. The most important point here is that you cannot make this decision based on storage space. It is a complete wash.
Okay, so since capacity is completely off the table, we can now focus on the things that truly matter. The real choice here isn't about space at all. It's a direct trade-off between raw speed and absolute data protection. And this is where these 2 contenders really start to show their differences.
Let's kick things off with performance, specifically random I/O operations per second, or IOPS. This is super critical for stuff like virtual machines or databases. For striped mirrors, the performance is just fantastic. Because remember, your pool is made of 2 VDEVs, so your pool's IOPS are roughly double a single disk's performance. For RAID Z2, though, it's a completely different story. The IOPS are shockingly low, basically limited to the performance of just a single drive. And we're not talking about a small gap here. It is a massive architectural difference.
And hey, you don't have to take my word for it. Here's a quote from a true NAS community user that just perfectly captures the real-world impact of low IOPS. Running virtual machines on a RAID Z2 setup feels like they're running in treacle. I mean, what a fantastic way to describe a very real performance bottleneck.
Okay, so what about protection? Well, the striped mirror offers what we can call probabilistic fault tolerance. It is 100% guaranteed to survive any single drive failure, no problem. If a second drive fails, its survival kind of comes down to chance. You've got about a 2 in 3 or a 67% chance of survival. RAID Z2, on the other hand, offers absolute fault tolerance. It is guaranteed to survive the failure of any 2 drives in the group, period. So on paper, RAID Z2 looks way safer.
But, that's not the whole story. The safety of a system isn't just about how many drives can fail, it's also about what happens during the recovery process. And this leads us to this really fascinating and kind of counterintuitive idea I like to call the recovery paradox.
So let's look at recovery, or resilvering on a striped mirror. When a drive fails, ZFS simply copies all the data from its one surviving partner over to the new replacement drive. The other mirror pair? It's completely unaffected, just chugging along. The result is a really fast, really low-stress operation that barely impacts the rest of your system.
Now, let's compare that to RAID Z2. When a drive fails here, it is an all-hands-on-deck emergency. ZFS has to read from all 3 surviving drives at the same time, run these intense calculations, and reconstruct all the missing data from parity. This just hammers every single one of your remaining drives at 100% load for hours, sometimes even days. It is a slow, incredibly high-stress event for your hardware.
And this brings us right to the paradox. The most dangerous time for any storage array is during a rebuild. That intense stress is what's most likely to cause another drive to fail. So RAID Z2's safer guarantee of surviving 2 failures is, in a way, a necessary defense against the higher risk of failure that its own stressful recovery process creates. The striped mirror, on the other hand, rarely even needs that level of protection because its recovery process is so fast and so gentle.
So after all that, with capacity being a tie, and this clear trade-off between performance, protection, and recovery stress, how do you make the final call? Well, this section is all about your specific workload. Let's just break it down into a simple checklist. Okay, you should absolutely choose striped mirrors if your world revolves around performance. If you're running virtual machines, databases, or really anything that needs high IOPS, this is the only real choice. It's also the better option if you value fast, safe recovery times, if you're working with a lower power CPU, or, and this is a good one, if you want the flexibility to easily add just 2 more drives to expand your storage later on.
On the other hand, you should definitely choose RAID Z2 if your workload is all about bulk storage. If you're building a media server for Plex, a long-term archive, or a backup target, IOPS just don't matter. In that case, you might prefer the absolute peace of mind that comes from knowing any 2 drives can fail without data loss, and you're willing to accept that slower, higher stress recovery process that comes along with it.
Now, one last thing, and this is a really crucial tip. When you're using graphical tools like NAS, it is surprisingly easy to make a mistake. If you select all 4 of your drives and then just click Mirror, you might accidentally create a 4-way mirror. Now, this setup has incredible redundancy. It can survive 3 drive failures, but it leaves you with only 25% of your capacity. For almost everybody, that's a terrible trade-off. So make sure you're creating 2 separate 2-drive mirrors.
So there you have it. That 50% capacity standoff means your 4-drive decision isn't about space, it's about your specific workload. Are you building a high-speed workhorse that needs performance, or a rock-solid media vault that prioritizes absolute protection? The answer to that question tells you exactly what you need to know. Thanks for tuning in.